Today we're going to talk about a little introduction to trigonometry, which I know that all of us have a little bit of background on trig from geometry, but we're going to talk in greater detail about it. The very first thing we're going to start with is we're going to start talking about this right triangle here. So I'm going to add in the right angle symbol right there. Now, one of the things that we're going to do a lot is we're going to label vertices and sides. And the way we traditionally do that is when we label a vertex of a triangle, we tend to use capital letters. Like, for instance, if I call this A, I call this B, and I call this C. And then when we label the side, we correspond the side opposite the angle with the lowercase letter. So, for instance, if this is angle A, the opposite side, that would be lowercase a. If this is angle B, side opposite, that would be lowercase b. And then C opposite would be lowercase c. And the reason why we do that is because then when we talk about side C or angle A, it's pretty easy to be able to match them up with the side opposite. Okay, now let's talk about the 6 different trig functions. Now, a lot of us already know that kind of strange word SOHCAHTOA. So I'm going to write that, and I tend to write it a little different than most people. The way I like to write it is this. I write SOHCAHTOA. And most of us already know some of this stuff. The S, the C, and the T stand for the 3, I guess, basic trig functions, and that would be sine, cosine, and tangent. And we know, or hopefully we know, that sine, now if I say, instead of referring to, let's say this angle right here is A, let's call the inside of it, or the measurement of it, a value. And since we're talking about trig, and trig is a Greek topic, we tend to use some Greek letters when we talk about the angles. So keeping with that tradition, why don't we call this angle right here, that is the symbol theta. So if I'm asking you what is the sine of theta, so sine, which is S-I-N-E of theta, would equal, remember it's opposite over hypotenuse, so opposite over hypotenuse. And then we have the next one being cosine of theta. Cosine stands for adjacent over hypotenuse. And then we have the last one, which is tangent. Which is opposite over adjacent. Okay. Now, there are actually 3 other trig functions. Okay. The first one being what we call cosecant. Cosecant. Now, cosecant is the same thing as, or cosecant of theta is the same thing as 1 over sine of theta. Now you notice that the abbreviation for sine is S-I-N. Just drop off the E. So since sine of theta is equal to opposite over hypotenuse, then cosecant is going to be just flipped around. So it will be the hypotenuse over opposite. The next one is secant. Of theta, which is 1 over cosine. And you notice that cosine, the abbreviation is COS. Okay, and since cosine is adjacent over hypotenuse, and secant is hypotenuse over adjacent. The last one is what we call cotangent. Which is 1 over tangent. And tangent, the abbreviation is tan, T-A-N. And since tangent was opposite over adjacent, that cotangent is adjacent over opposite. Okay? Hopefully that makes a little bit of sense. Well, these new ones right here maybe doesn't make any sense, but these are three new ones, and basically they are just the reciprocals of the ones next to them. Okay? So there's 6 basic trig functions, and they're all based upon hypotenuse, opposite, and adjacent. And those are all things that hopefully you've talked about before. So let's move down here and let's talk about a couple examples here. So for instance, let's say, let me zoom in here a little bit. Let's talk about this one here. Let's call this theta. And let's call this side 5. This is 12 and 13, and this is a right angle. So if I say find the 6 trig functions, so let's go through and label them all. So let's start with, I'll list them first. We have cosine of theta, we have sine of theta, we have tangent of theta, we have secant of theta, cosecant of theta, and cotangent of theta. And now notice the abbreviations for those last 3. Secant, cosecant, and cotangent. So let's just start by listing them. Okay, cosine. Cosine is adjacent over opposite. So that would just simply be 12 over 13. Okay, sine. So that would be opposite over hypotenuse. So that would be 5 over 13. And tangent would be adjacent, or pardon me, opposite. So opposite over adjacent. So it would be 5 over 12. And once you know those, then the rest of them should be pretty easy. Now secant, the things that you have to keep track of is, what is secant? Well, secant is 1 over cosine. So flip your cosine upside down and you get 13 over 12. Cosecant. Cosecant is sine flipped over, so it's 13 over 5. And cotangent, flip tangent over, 12 over 5. And there you go, just like that. Okay, so any right triangle, you should, given certain information obviously, you should be able to come up with the 6 trig functions. Okay, so let's try another one. I'm going to have you, this would be a good one for you to try first on your own. Be a good one for you to hit pause and try this. So let's say I tell you that this is theta, this is a right angle, and this is 25, and this is 24. And I want to know what are the 6 trig functions. So hit pause and give it a shot. Well, in order to do this, the very first thing you actually have to do is you have to actually figure out what this side is. So if you do some Pythagorean theorem, and you do, let's call that x just for now, you'd say x squared plus 24 squared equals 25 squared. If you went through and figured all that out, you end up with x equals 7. So that's the very first thing. The next thing is, let's figure out what all our stuff is. So I'm going to write them out again. So cosine of theta, sine of theta, tangent theta. Over here I'm going to put secant theta, cosecant theta, cotangent theta. Alright, so cosine of theta. Hopefully you came up with cosine to be 24 over 25. Hopefully you came up with sine to be 7 over 25. Tangent, 7 over 24. Okay. And then these, one should, and especially if you list them like this, it's pretty easy. Secant then would be just be 25 over 24. Cosecant would be 25 over 7. And cotangent 24 over 7. And there you go. Okay, so hopefully so far we're kind of following along. let's talk about another example here. Now I have some things left out here, so let's try this one. Here it says, given, now let me throw this in here. Given that sine of theta is equal to 4/5, find the other 5 trig functions. So if I tell you that there's some triangle out there that has sine of theta equal to 4/5, we should be able to come up with the other parts. So one way to do it, or come up with the other 5 trig functions, pardon me. One way we can do it very easily is, let's just make up a triangle. Okay, we know it's going to be a right triangle. Okay, and this is a right angle. Now it doesn't really matter, let's just name one of the angles theta. Let's call that theta right there. So what does sine stand for? Well, sine stands for opposite over hypotenuse. So opposite over hypotenuse. So then the question is, what is this side right there? Well, let's see, if you do Pythagorean theorem, or if you remember your Pythagorean triples, this side right here would have to end up being 3. So based upon that, we can come up with all of our other trig functions. We can come up with cosine of theta, tangent of theta. So let's start with cosine of theta. That would be 3/5. Tangent would be opposite over adjacent, so that would be 4/3. Cosecant of theta would be 5/3. Secant, pardon me, not cosecant's not 5/3. Cosecant, remember, is flipping sine over, so it would actually be 5/4. While secant of theta would be 5/3, because that's 1 over cosine. And cotangent of theta would be 3/4, just like that. Okay? Hopefully, so far so good. Alright, next, let's talk about actually finding some stuff here. Let's start with this example here. So we have a triangle here. Now nothing's labeled on it, I'll label it in just a second. Let's say that, let's go right triangle again. Let's call this X, let's call this side 18, and this is 31 degrees. So how do I figure out what X is in something like this? Now this might have been something that you've already done before, but let's see if we can come up with the idea. Now, in order to figure this out, we're going to come up with a trig equation here. So based upon this angle right here, what sides do we have? Well, based upon this, we obviously have hypotenuse, because that's opposite the right angle. But we also have the adjacent. So which trig function uses adjacent and hypotenuse? Well, that trig function is cosine. So I would write this equation. Cosine of 31 degrees equals adjacent over hypotenuse. Now, how do you solve that? Well, one of the problems that we have right now is that this X is in the bottom right here. So what I'm going to do to get that out of the bottom is I'm going to multiply both sides by X, or X over 1. So then I get X times cosine of 31 degrees equals 18, because those cancel. And then I'm going to, because we're trying to get the X all by itself, I'm going to divide by this cosine of 31. One of the things that you really need to understand is the fact that cosine of 31 is one thing, if you will. It's not cosine times 31. It's together. It's cosine of 31 degrees. So it's not like it's something we can break up. So these would cancel. And we get X equals 18 over cosine of 31 degrees. And if you remember, this is what we were calling, from a previous chapter, calculator ready form. So we get it to this point. Now let's use our calculator. So we're going to take 18 and divide it by, now you have that cosine button on your calculator, and type that in. And if we go to, let's just nearest whole number, we come up with X to be about 21 units long. Okay, let's try another one. What about this one right here? Let me fill in some info here. Let's say we call this X, and this 5, this 12, and make it a right triangle there. And this time again, I want to know what X is equal to. So, based upon this angle right here, what sides do we have? Well, we have opposite and we have adjacent. So what trig function is that? Well, that would be tangent. So I'd write tangent of X equals opposite over adjacent. So how do I solve that? Because you're not going to divide by tan. That doesn't make any sense, because like I said just a minute ago, it's not tan times X, it's tangent of X. So one way we're going to solve this is we're going to take the inverse tangent of both sides. So in other words, and I'll write it down here, I'm going to take the inverse tangent of this side, and I'm going to take the inverse tangent of that side. Okay, and when you do that, what'll happen is that these essentially cancel one another out, and we end up getting X. And on the right side, I get this. Okay, now on your calculator, you have an inverse tangent button. You'll see it's right above the tan button, the TAN button. You'll usually have to hit second or shift. And what that's going to then do is it's going to tell us what angle will make this true. And so if I hit inverse tangent of 5/12, you should try that too. And if we round that to, let's say, the nearest tenth, you should come up with X to be 22.6 degrees. Okay, so when I am actually doing inverse tangent, so this little button right there, that tells us what angle will give us this ratio of 5/12. Okay, let's keep moving. Let's talk about the next one. So the next equation we're going to look at is this one. It says cotangent of theta is equal to 3/4. And we want to know what theta is. Well, just a minute ago when we wanted to know, when it said tangent of X equals 5/12, we did inverse tangent to figure that out. But what you'll notice on your calculator is it doesn't say, there's no cotangent button on there. So what we need to do is we need to try and rewrite this equation so it says tangent, cosine, or sine. Because then we can do an inverse sine or cosine or tangent. And so what we're going to do is this. Cotangent is the same thing as 1 over tangent. So I'm just going to rewrite it. This is the same thing as 1 over tangent of theta. So I didn't really do anything. I just rewrote cotangent in terms of tangent. And if you go back to the very beginning of our notes, that's exactly what we put up there in that little box. Well, what we have there is that we essentially have a proportion. So I could, if I wanted to take our time here, and we can just cross multiply, we end up with 4 equals 3 tangent theta, and then I could divide by 3. 4/3 equals tangent theta. Alright, now I have a problem just like what we got done doing in the last example. So in order to figure out what theta is, I'm going to take the inverse tangent of both sides. So I'm going to take the inverse tangent of 4/3. I'm going to take the inverse tangent of tangent theta. Essentially, these cancel. Let's move this up over here. And then, so what we're left with is inverse tangent of 4/3 equals theta. So I'd take my calculator, inverse tangent, 4/3, and if we go nearest tenth of a degree, we would end up with 53.1 degrees is equal to tangent. Okay, so the moral of the story here on this one is, if your equation doesn't have one of the big three being sine, cosine, and tangent, you need to try and rewrite it. So it says sine, cosine, or tangent, and then eventually you can do an inverse sine, inverse cosine, inverse tangent. Let's take a look at this one right here. Okay. So how on earth would I figure this out? Oh, well, first of all, sorry, I have a little bit of a typo here. So let's just say instead of cosecant is 48.6, that doesn't make much sense here. Let's say I said cosecant is equal to 2/3. Let's just do that. Well, if it is equal to 2/3, well, again, I'd love to be able to do an inverse cosecant, but I can't. So what I need to do is rewrite it so it says sine, cosine, or cosecant, or probably sine, cosine, or tangent. Well, cosecant is the same thing as 1 over sine. So now if I cross multiply everything, you can say 2 sine theta is equal to 3. Divide by 2. Move it on up. We get sine theta equals 3 over 2. So similar to what we did with tangent, we will take the inverse sine, inverse sine, inverse sine of this. So essentially we would get theta is equal to the inverse sine of 3 over 2. And if I did the inverse sine of 3 over 2, what do you get? Well, what you're going to get is error. Okay, so, or no solutions. So basically this is saying this is impossible. Okay, well the question is, why is that impossible? Well, the easiest way to think about it is this. If we go back to this equation right here, sine is equal to 3 over 2. Remember, sine is equal to, sine of theta is equal to opposite over hypotenuse. Well, let's see. If this is saying that sine is equal to 3 over 2, this is saying that we have a triangle that has a side that is bigger than the hypotenuse, which that's impossible. Remember, the hypotenuse, which is opposite the 90-degree angle, always has to be the longest side. So this is saying that since this is trying to tell us that the side opposite is 3 and the hypotenuse is 2, well, that's a problem. And that can't exist. That's why we come up with an error in that situation. So there are times when we solve these that are essentially just impossible situations. Okay, let's try. We got a couple more here. We got 2 more here that we would like to try. So let's try this number 7 here. Okay, it says solve the right triangle given this information. All right. One thing I'm going to throw in here real quick. We're going to given C is a right angle. Okay, so this says that A is 14 and B is root 6. Now notice that it uses capital A here, so that tells us that's an angle, and lowercase b, it tells us it's a side. So if I try and draw a picture, okay, and the picture doesn't have to be perfect, but at least it's a right triangle. That's all we really care about. That's C. And I'm just going to call this A and this B. So if I just fill in some info, this is 14 degrees. Side B is root 6. It says solve the right triangle. Okay, well, what I'm referring to when we say solve the right triangle is I'm saying find all the rest of the parts. So what are some other things that we know? Well, one thing that we can tell right away is this angle right here. Remember, the triangle sum, or the angle sum theorem here says that all three angles always add up to what? Well, they always have to add up to 180 degrees. So this is 90 and that's 14. This angle right here has to be 76 degrees. Next, how do I figure out these parts right here? So to figure out the other parts, and I'm going to label them, we'll call this A and this C. If I want to know either one of them, I have to come up with some trig equations. So let's look for, let's see here. Let's come up with A, I guess. So if I want to know what A is, I'm just going to use a trig equation. So let's say I use tangent. If I want to do tangent, I'm going to use this angle. Tangent is opposite over adjacent. So an equation I can come up with is tangent of 14 degrees equals opposite over adjacent, just like that. Now, to solve that, what I would do is I'm going to put it in calculator ready form. So I'm going to multiply both sides by root 6. So I get root 6 tan 14 degrees equals A. Zoom in just a little bit. So that's my calculator ready form. So I'm going to take my calculator and multiply root 6 times tangent of 14 degrees, and what I'm going to come up with, hold on one second, times root 6 is, if I go, let's say, nearest tenth, I'll come up with 0.61. I'll go nearest hundredth, I guess, 0.61. Okay? So, what then? Well, in order to figure out the last part, that angle C, you could do a couple things. You could do another trig equation. You could also, since we now know that this is 0.61 right here, I could do Pythagorean theorem. I could very easily set up root 6 squared plus 0.61 squared equals C squared. If I did all that, and let's see, I come up with that. Let me just type it into my calculator real quick. And we come up with C is 2.5. Okay, so not terribly difficult to be able to figure those parts out. Okay. Very last thing. Okay, and this would be a good one for you to kind of try on your own here. It says solve the right triangle. So basically the same idea. And I give you some parts. Let's once again just assume that C is a right angle. Okay, so you should try and see if you can come up with the missing parts. Okay, so hit pause and give it a shot. Okay, so hopefully what you did was first just draw any old triangle. Okay, as long as it's a right triangle, it doesn't really matter whether or not it's accurate or not. At least you get an idea. Call that C, I'm going to call that A, I'm going to call this B. And now I'm going to fill in stuff I know. Let's see. As far as B is concerned, this is 45 degrees. And then it says A is 6. So this is my B, this is my C. So we have to figure out those parts and angle A. Well, angle A we can start with. If that's 90 and that's 45, obviously then this has to be 45 degrees. And now, if you notice, this one's actually quite easy. You notice that since this is a 45, 45, 90, that means it's isosceles. So therefore, this one would have to be 6 also. And then to figure out C, pretty easy. You can do C squared equals 6 squared plus 6 squared, or C squared equals 36 plus 36, C squared equals 72, and if you take the square root of 72, we end up with 8.5. So this one, you didn't even need a trig function even to solve this one. This was pretty simple, and keep that in mind. You know, you don't always, there are situations where you don't need trig functions. Now, could I have done a trig function? Sure, I definitely could have. I could have done, you know, like the sine, or probably the tangent of 45 to get this over this and solve. I mean, you definitely could do that, but sometimes it's not quite, it's not necessary. So anyways, hopefully that gives you a little insight into some trig and applying trig with some of these. We'll do obviously more of these once we get into class.